Hey everyone. So this is our part 2 of types of agents. So in the part 1 we have discussed about the simple reflex based agent and the model based reflex agent. In this particular video we are going to see the next two agents. So the first one in the types of agents or in the part 2 is the goal based agent. An AI agent which makes decision by looking at the current situation, that is nothing but state, and what goal it wants to achieve, can be defined as the goal based agent. It also chooses actions that helps it to reach the goal. It uses a model to understand how the world works and a goal to decide the best path. It thinks about the future. A goal based agent asks questions like, what will happen if I do this? What will help me to reach the goal? It uses search and planning. So it is not just like the previous ones. It uses the searching and planning methodology. If finding a goal is easy, then it takes one step towards reaching the goal. If finding goal is hard, then the agent uses search and planning to reach the goal and make guesses of the path it has to take. Here an important point is there. A goal-based agent is different from reflex agents. The reflex-based agents just react without thinking, but the goal-based agent do think before reacting. Reflex agents just react without thinking, but whereas goal-based agents do think before reacting. Let's understand this concept with an example. If the car in front is braking, a reflex agent just simply applies brake, but a goal-based agent thinks in this way. The car will slow down, so I must also slow down or I might crash. So instead, I'll just apply the brakes to stay safe. So this gives the a better understanding of the goal based agent working. So let's look at the diagram of a goal based agent. So this is the diagram of a goal based agent in AI. So it has various components. It has environment. In agent component we have sensors, what the world is like now, what it will be if I do action A, what action I should do now, actuators, goals, what my actions do, how world evolves, and the state. So let's look into the working and each component of this particular agent. So firstly, we have this sensors to what the world is like now. So in the diagram we can see the sensors is directly connected to the what the world is like now. So what happens between these two? The agent uses sensors to observe its current state. I'm in a room A and it's dirty. The next one is state or memory. The agent keeps track of what it already knows. The agent keeps track of what it already knows and it remembers what it saw and did earlier. It uses the state to perform the particular action. How the world evolves. The agent knows how the world changes over the time. So this particular component helps to understand how the world changes over the time. So with this particular same example, if I'm in room A and it's dirty, if I move right, I will be in room B. So we know that the vacuum cleaner example in our previous videos. So I'm trying to explain this particular concept using the same example. So the next concept is what my actions do. It knows what its actions can cause. What this particular component I have discussed just now. So this component explains what the actions the agent is performing can cause in output. So it is aware of the actions and their causes. it will be like if I do action A. Now the agent thinks ahead and imagines, if I do this action, what will the world look like? So this is the component. So it has multiple actions to perform, but the agent takes one action and guesses like what it will be like if I do action A and how it changes the environment. The next one is goals. The agent checks, will this future situation help me to reach my goal? The AI agent asks this particular question to itself. If it gets a reply or the response as no, then it won't take the particular action. It changes to the another action. In the vacuum cleaner example, we have discussed that the goal of that particular smart vacuum cleaner is to make all rooms clean. If the imagined future move towards the goal, then the action is good. What action I should do now? So this is the ultimate or the end decision which an AI agent or a goal-based agent takes. So this particular action or the decision is based on what it sees, what it knows, what it imagines, and what it wants ultimately. That is the goal. So based on these particular four factors, it chooses the best action. The last component is actuators. The agent now performs that action in the real world or the environment using its actuators. Just as in the smart vacuum cleaner example, that vacuum cleaner cleans, moves, or picks something up. The advantages of goal based agents are it is flexible, it can easily change its behavior when the goal changes. Smarter decisions, thinks ahead and chooses actions that help in the long run and to reach the goal. It is easy to update. If something in the environment changes, the agent can just adjust its action based on the new knowledge. It also has some disadvantages like slower than reflex agents. It takes more time to plan and think. More complex. It needs a clear and a formal goal information and planning capability. So it can be said as it is better than the previous ones, but it do have some disadvantages. So the last AI agent is utility based agent. A utility based agent is smarter than a goal based agent. It doesn't just aim to reach the goal, it tries to choose the best, happiest outcome. It uses a utility function to measure how good or satisfying each possible state is. So we have seen that in goal based agent, it tries to reach a goal, but in the utility based agent, it uses a utility function to measure how good the particular decision or how good the particular goal is going to be, and it chooses the best and happiest outcome. Not just, it doesn't just want to achieve the goal, but it wants to achieve the best and the happiest outcome. What is mean by utility function? A utility function gives a score to each possible outcome. It tells the agent how much it likes each result. If the utility function matches the performance measure, the agent will act rationally. What is utility? I have discussed what is mean by utility based agent, a utility function, but ultimately what is mean by utility? Utility means a measure of how good or desirable a situation is. It is like a happiness score for the AI agent. So computer scientists and economists use this word utility instead of happiness in their fields of work. So goals alone are not enough to make the best decisions in the most environments. A goal based agent only cares about reaching the goal. Yes, we have discussed this point just now. It doesn't compare with option which is far better than the chosen one. We need something more advanced to choose the best way to achieve the goal. This is where utility comes in, and this is why we need utility based agents. So we do have some example to understand this concept easier. A taxi driver's goal is to take the passenger to the destination. Many routes can achieve this goal. Some routes are faster, some routes are safer, some routes are cheaper to travel. So, the goal based agent, if we consider this particular example, in according to the goal based agent, it doesn't care about the faster, safer, cheaper, etc. routes. Just cares about to take the passenger from the pickup point and to drive him to the destination. That's it. But whereas the utility based agent considers some options like the faster route, the safer route, and the cheaper or the affordable route. Such like it takes some options. So why agents are better? Utility helps in two important situations. When there are conflicting goals, utility decides the right balance. When goals are uncertain, utility helps to compare the chances of success with the importance of goal. And decision making under uncertainty. The real world is often uncertain. It has partial information, random events. It isn't structured and formal as it is in theory. A utility based agent chooses the action that gives the highest expected utility. Expected utility is nothing but the average utility of all possible outcomes, weighted by their probability. So let's take the same example, the previous one we have discussed just now, the taxi example. So a taxi driver wants to drop the passenger to the destination. So he has two routes, the route A, the route B. Route A is faster, but it's risky. So the utility score will be 70. But the route B is slow, but it's safe. So the utility score will be 90. So automatically the rule based agent or the utility based AI agent in the taxi will choose the route B because it has higher utility. That's how the utility based agents work. Let's look at the diagram of utility based agent. So this is the complete diagram of utility based agent. Same, we have the environment, agent, actuator, sensors, but yeah, some components do change. What the world is like now, same as before. What it will be like if I do action A, same as before. How happy I will be in such a state. This is added due to the utility based agent. What action I should do now? It's also same as before. The state, just as previous. How the world evolves, just as previous. What my actions do, same one. The utility function, it's changed. So same, let's go to the step by step working of the complete utility based agent. So the first one, sensors to what the world is like now. As we have discussed earlier, it is same for the model, goal, and utility based agent. The agent first observes the current situation using sensors. Same. State or memory. The agent remembers what it already knows about the world. It keeps track of where it is and what happened before. How the world evolves. The agent knows how things change when it acts and how the world evolves over the time. What my actions do. It knows what results each action might produce. What it will be if I do action A. The agent imagines future situation after taking each possible action. The utility to how happy I'll be in such a state. It uses a utility function to assign a number or a happiness score to each of the imagined state. So the same vacuum cleaner example, room A is clean but small, then the score is 6 by 10. And the room is clean but big, it's 9 by 10. The dirty room is 2 by 10. That's how it assigns the happiness score or the utility function. Expected utility. If an action might lead to multiple outcomes, it calculates the average utility based on probability. It picks the action that gives the highest expected happiness. What actions I should do now? The agent compares all the future states and picks the action that gives the best utility value. And we know that actuators. The chosen action is performed in the real world using actuators. They move, clean, turn, speak, etc. actions they do perform using actuators on the environment. So let's discuss the advantages of utility based agents. Better decision making. Chooses the best action, not just any action that meets the goal. Handles conflicting goals. Can balance trade offs. That is like whether it is important to go to the destination in a faster route or in a safer route, such options. It works under uncertainty. It uses expected utility to make decisions even when outcomes are uncertain. Flexibility. It can adapt to changing situations and priorities. Performance oriented. It focuses on maximizing the results, not just completing the task and staying static. It do have some disadvantages. Complex design. It needs detailed modeling of the environment and possible outcomes. High computation. Calculating the best action can make a lot of processing power. Difficult to define utility function. Assigning accurate happiness scores to every possible situation is hard. Requires accurate data. If input data is wrong or incomplete, decisions can be bad, not always perfect. Computational limits mean the agent may not always find the truly best choice. So, this is about the utility based AI agent. So, we have covered the goal based agent and utility based agent in the part 2, and the first two are covered in the part 1. So, this is the complete unit 1 of artificial intelligence. So, this is for this video, and we'll meet in the next video. Until then, keep learning.